Okay, last three warm-ups. You're going to learn that there's a difference in how you handle significant figures when you're adding, subtracting, or multiplying and dividing. So you need to get those down. So we're going to look at an example here of how you handle significant figures when we are adding values together. In this case, you can see we've got quite a spread of different significant figures. So we're asked to use the rules for significant figures to find the answer to the addition problem. So in looking at this, adding the three numbers with the calculator gives us 21.4 plus 15 plus 17.17 plus 4.003 for an answer of 57,573. Which, when you look at your calculator, you'll think, okay, that's it. The calculator says that's the answer. That's the answer. No, it is not the answer. The next step is you, with your mind, has to take a look at this and say, okay, do I have accuracy problems? Do I have significant figures to deal with because of those accuracy problems? And yes, you do. Because if we look at all of the terms that were added together, 15 is the least accurate. It is only two significant figures. So your answer cannot be any more accurate than two significant figures because of the 15. So 0.573 is an inaccurate answer. Okay? So the answer must be rounded then to contain the same number of significant figures as the least accurate number in the sum, which is 15. So therefore, we need to round 57.573 up to two significant figures. So to do this, we look at each of the terms in the decimal portion. 3 rounds down, so the 7 remains. 7 rounds up, so it goes to 6. 6 rounds up, so the next value up goes to 8. So therefore, the correct answer to two significant figures is 58. Okay, looking at coordinate systems. You're going to be using coordinate systems a lot in this class. So we need to look at the difference between Cartesian coordinates and polar coordinates. And you're going to be doing conversions between the two. So in this case, they gave us a point that's located at -5 and 12 on the Cartesian system. Everything to the left on the x-axis is negative. Everything to the upper portion is positive. Everything below the origin is negative. So we want to look at this in terms of converting from Cartesian -5 and 12 to polar systems. So to do this, we're going to learn that we have some mathematical procedures that we have to go through. And these procedures are going to be very important in you learning how to do vector representations, because you will have to convert from one form to the other. The given Cartesian coordinates then are x equal -5 and y equals 12. The least accurate of these coordinates contains 3 significant figures. So we'll express our answer in 3 significant figures. The specified point, -5.00, 3 significant figures, and 12 is in the second quadrant since x is greater than 1, y is greater than 0. Or x is greater than 0, y is greater than 0. To find the polar coordinates, r for radius and the angle theta of this point, we have to use 2 mathematical expressions. The first expression is part of the Pythagorean theorem. And it merely says that the radius, which will become our vector that we're going to use later on, is squaring the x term, adding it to the square of the y term, and then coming up with a value of 13. So the radius in this case, x squared plus y squared equals 13. And to get the angle, the tangent is equal to the theta is equal to the inverse tangent of y by x, which equals the inverse tan of -1, 12 over minus 5, which gives us an angle of minus 67.3. But we have to do one more step in the conversion. Since the point is in the second quadrant, we add 180 degrees to this angle to obtain an angle of 113 degrees. So we're going to essentially subtract that 67.3 from 180, and that's going to give us an angle of 113 degrees. So the coordinates in polar form for minus 5 and 12 is 13, that's the radius, and 113 as the angle. Finally, using the trigonometric relationships to determine a side of a triangle. At a horizontal distance of 45 meters from the bottom of a tree, the angle of elevation to the top of the tree is 26 degrees. How can we find that value h? Okay, so we've got the horizontal distance, 45 meters to the base, and the angle of 26 degrees. So to do this, what we're going to do is we're going to take the tangent of 26 degrees. By definition, is h over 45. Later, we're going to find out that h is the side opposite, and 45 is the side adjacent. Okay, so opposite over adjacent is for tangent. Take the tangent of 26 degrees, and what we're going to do now is we're going to move the terms around to solve for h. So if we multiply 45 meters times the tangent of 26 degrees and times the itself in the denominator, we get the height is equal to 45 meters times the tangent of 26 degrees gives us 22 meters. Okay, so this is just a run-up. These problems are just a run-up of what you will see, or what you should have seen in Chapter 1 to prepare you for the type of math that you are going to experience for the rest of EGG 131 Technical Physics. Thank you.